Hello, I am Tim Komar, and today we're going to talk about parallel lines, including an SAT type example. First, two distinct lines in the plane are parallel if they do not intersect. Intuitively, we can think of parallel lines as lines that go in the same direction. We now discuss how to characterize parallel lines algebraically. First of all, any two distinct vertical lines are parallel. Here we have x equals -2 in red and x equals 3 in blue over here. And those are two vertical lines. Two distinct non-vertical lines in the plane, with slopes m1 and m2, are parallel if and only if their slopes are equal. That is, m1 equals m2. We have an example down here where we have the line y equals 2x plus 3 in red and the line y equals 2x minus 1 in blue. So in the slope-intercept form, we can recognize non-vertical parallel lines as lines that have the same slope and different y-intercepts. That is, y equals mx plus b1 and y equals mx plus b2 are parallel if and only if b1 doesn't equal b2. That is, they have different y-intercepts. For example, the lines that we had on the previous slide, y equals 2x plus 3 and y equals 2x minus 1 are parallel since the y-intercept coordinates here, 3 and -1, are not equal to each other. Caution here. Two lines have the same slope and the same y-intercept. They are indeed the same line. We do not say that such lines are parallel. For example, if we have the line y equals 2x plus 3 and the line y equals 2x plus 3, well, they describe the same line and are not considered parallel. So here's our example. Let's find the value of p so that the two lines given below here are parallel. The two lines are px equals 5y plus 10 and 6x plus 10, y equals 12. So first, let's rewrite the system so that both equations are in standard form. Here we have px minus 5y equals 10, and the second equation is the same, 6x plus 10y equals 12. So, if we have a line given in standard form, like ax plus by equals c, where the coefficient b is non-zero, the slope is -a over b. So if we use that formula for the slopes of the two lines on the previous slides, we're going to get that the slope of the first line is p over 5, and the slope of the second line is -6 over 10. Solving for p by multiplying both sides of that equation by 5, we're going to get that p is 5 times -6 over 10, which is -3. Well, we still need to check that the lines do not have the same y-intercepts over here, just to be sure they're not the same lines over here. So if we substitute p equals -3 into the first equation, and we divide both sides of the second equation by -2, we obtain the following. -3x minus 5y equals 10, and -3x minus 5y equals -6. Since the left-hand sides of both equations are the same, and the right-hand sides are not equal, we can conclude that the lines have different y-intercepts, and hence the lines are indeed parallel. So again, I'm Tim Komar. I am a mathematics tutor. You can get a hold of me at that email address or my website over here, and I will tutor anything for you in high school, college, even middle school mathematics, and look forward to working with you. Take care.